My name is Ron Dorn. I apologize for the audio quality, but I had trouble with getting my headset working. But I want to get this video out to help students as soon as possible. This is a video about stage 0 in the Hawaii lab question 2. What is the average depth of the Polulu River Valley? I'm going to take this from a perspective of somebody like me who doesn't really know how to play video games and walk myself through doing this lab. I'm going to screen share so you can see what I've got on my screen and what I'm doing. And hopefully it won't be a waste of your time and it'll help you. I'm in the Hawaii game right now. I'm hitting escape so I'm able to manipulate my own computer. I'm going to question 2, which is what's the average depth of the Polulu River Valley with different precipitation values, isohyets along the way, 2150, 2800, 3200, and 3500 millimeters of isohyet precipitation. So I'm going to, in the game, fast travel or jump to the latitude and longitude locations indicated. So I'm going to hit the menu over here, hit fast travel, and enter the latitude. And then I need to go grab the longitude. I can either type these in or I can copy and paste them. So now I am at this location on the inset map. I hope you can see it. I'm on the rainy part of the Big Island of Hawaii of the Kohala volcano, and I'm changing my mouse so I can zoom in and zoom out so I can see the overall perspective of the Kohala volcano, the rainforest on the trade wind or the east facing side. And I'm going to click on the rainfall here so you can see that as you move up the volcano, it gets rainier and rainier. And then near the top, it begins to get drier again because of the trade wind inversion. It gets rainier as you go up initially because of the orographic uplift of the trade winds to produce clouds and rainfall. I'm going to click back on the Landsat layer and start in on the question. I'm on the western ridge of the Polulu River Valley, and I'm at the location where the measurement needs to be made. It's about 2150 millimeters of rainfall or isohyet, and it's an elevation of 215 meters. And I can see that in the box of the data readout of where the avatar is now standing. So I'm instructed to go down to the bottom of the river valley. I'm hitting escape to make me go into game playing mode, and I'm hitting the arrow to go down to the bottom of the river valley, and I need to walk towards the coastline to get to the 2149 millimeters of precipitation, which is 35 meters. So what I've done ahead of time is to copy the information into a Microsoft Word file for note-taking. The elevation above the ridge is 250 millimeters, 35 meters down in the river valley, and when you subtract the two, it's a depth of 180 meters. So now I need to walk up the river valley and get to around 2,800 millimeters of precipitation. I go back into the game, I hit escape, and I begin to walk up the river valley. Note that as I go up the river valley, the rainfall increases. I'm now at about 2,500 millimeters. And now I'm at 2,800 meters. Down here, I'm not quite there, but right up in here, I'm not very good at this. I need to get a jumping head start. I'm at 94 meters of elevation in the river valley. So that's what I need to write down at about 2,800 millimeters of rainfall. Excuse me. So what I'm going to show you how to do is a trick to keep track of the locations on the ridge above. I'm going to take a screenshot, which is incredibly valuable, both in asking questions and in keep track of where you are in the game. If you don't know how to take a screenshot on your computer, just go to YouTube and type in how to take a screenshot on a Mac or how to take a screenshot on a Windows computer. I actually like the snipping tool better for Windows, even though I'm now on a Mac playing the game. So in this case, I can know that I need to go up here on the ridge line by this little indentation, or it's actually a waterfall. So I now know it's 94 meters at this location, 2,800 millimeters of precipitation. And I need to get a running head start. Not good enough. Come on, you can jump up there. There we go. Oop, I jumped too high. So I need to go to 3,200 millimeters of precipitation. I'm right there. Whoa, 3,200 millimeters. And so I'm going to write down 214 meters. 214 meters is below the ridge line. So again, I'm going to take a screenshot, know where I need to be when I jump up and when I eventually get to the ridge line up here. So now I have one more elevation to measure at the bottom of the river valley. I'm trying to get myself up on a ledge up there. Okay, I'll move along here. Ooh, I got myself up there. Okay, I'm on this ledge. See if I can jump up to this ledge. Oh, fantastic. What I am is not quite in the bottom of the river valley, but I need to creep along the ledge here to get myself up to this elevation, which is, whoa, 3,503, or about 3,500 millimeters of precipitation. At this elevation, I'm at an elevation of 455 meters. At this point, you may be wondering, why are there these cliff faces and these blocks in the elevation instead of a nice smoothing of topography like you can see in Google Earth? And the answer is that Google Earth's topography is not the data. In science, we deal with the data as it exists. The data are block data. It's grid cells at 30-meter elevation or at very best 10 meters of elevation for the Earth. And so we're portraying you the real scientific data, not the altered and probably incorrect way it's portrayed in Google Earth for good visuals. So I'm jumping up here to the step above where I measured the 455 meters. I need to go one more step up here. So on this step, I'm at 785 meters, well above the river valley at 455 meters. So I write 785 down. And the next stop down is about this location where I was above the next spot, which is 605 meters of elevation on the ridge line, above the spot that was above the spot that was 214 meters down in the river valley. And then the last step, which is a little bit below the indentation, is an elevation of 455 meters. So let me recant and review in these notes. I got 94 meters. 94 meters, 214 meters, 455 meters. And on the ridge line above, I got 455, 605, and 785. So now I'm going to cheat a little bit. And in these notes, I'm going to copy and paste into Excel. In Excel, I can enter an equation like this, equals 215 minus 35 is 180, equals 455 minus 94 is 361, equals 605 minus 605 minus 214, and 785 minus 455. But I didn't enter the equal sign. So here are the depths of the river valley at the 4 locations. And to get an average in Excel, I enter average of cell C1 through C4. And the average is 315.5. That's a very precise average. But if your numbers are a little bit different, that's just great. We expect the numbers that you get, the specific values, to be different than ours. The reason is that you're making scientific measurements in an interactive GIS or a geovisualization using real scientific data. when you make an observation, where your avatar is will be slightly different than where we put the avatar. We know this. And so the differences exist in the washout of the averaging process and then in the multiple choice selection. So let me go back to the Canvas question, where your choices are 320, 280, 360, and 410. Notice that they're 40 or more meters apart. And so slight differences in where you make measurements will make no difference in you selecting the closest answer. So 315.5 is closest to 320, and I feel confident that that's the correct answer. I hope this was useful to you, not a waste of your time. Sorry about the audio.